Hello, dear friends. Welcome to another edition of Building with Metis. We are super excited about having this new workshop with our friends from Secret Network. We have Shan with us. How are you doing today, Shan?
I'm doing well. Thanks for having me, Victor.
Yeah, it's my pleasure. I'm really looking forward to learn about the things that you guys are building and the services that you are providing. So please, explain us a little bit more. What is it that we are going to be talking about today?
Awesome. Hi, everyone. My name is Conrad. I do developer relations for the Secret Network Foundation, which is a Secret Network is a Cosmos L1 privacy chain. And what I'm really excited to be sharing today is how to enable cross-chain verifiable randomness from Secret Network to Ethereum, specifically to Metis. We're completely cross-chain compatible with Ethereum L2s like Metis, and we've had this amazing partnership where we now have cross-chain randomness and also encrypted payloads available on Metis. And so essentially what this means is that you can now use Secret Network, this L1 in the Cosmos, as a privacy chain for Metis, as a place where you can encrypt payloads, so have private data, things like private voting, private sealed bid auctions. The sky's the limit using Secret Network, as well as verifiable randomness. And the demo I'm going to do today, I'm going to showcase how to actually deploy your own Metis smart contract that can receive verifiable randomness from Secret Network. And then as well, we can also talk about how to do encrypted payloads if there's time at the end. But I definitely want to make sure that I leave time for questions at the end. And I'm just really excited to be here sharing this today because my experience in Web3, I started in EVM a couple of years ago. I did my first ever Web3 experience was going to a ETH hackathon at ETH NYC. And, a couple of years ago, the idea that we'd be able to be cross-chain compatible from Ethereum to other completely different ecosystems, it would have never seemed possible at the time. So I think there's been a huge advancement in tech in a very short time. And what we've tried to do at Secret is just abstract as much of this code away as possible to make this really simple for Metis developers to use. And I'm hoping that by the end of this tutorial, Metis developers will feel empowered to be able to have cross-chain randomness in a few clicks in a way that's cheaper and faster than competitors such as Chainlink VRF.
It's good. Before we dive in, I am going to be asking you to share your screen so we can get started. And just to be super clear, what would be like the top three, maybe applications that developers can take from this?
Well, I could actually start by just showing some demos that we've posted. And I think the top applications is anything that you need for confidential computation. So anything you want to make a private app, whether it's voting or encrypted order books or sealed bid auctions, anything that you need privacy for your application, you're going to learn today how to use Secret Network and specifically our bridge we call Secret Path to be able to do that on Metis. And the other use case I think is awesome is just what we're specifically looking at today is verifiable randomness. So anything where you need a random number in your application and you want it to be verifiable, decentralized, and on-chain, you can use Secret Network in a Metis Solidity smart contract. Yeah.
Sounds amazing. Sounds pretty straightforward. Now, if you can do me the favor and start sharing your screen, we can get started with the coding session.
Perfect. Let us see.
Sure.
All right, let me know. I'm trying to share the entire screen. Let me know if you're able to see that.
Yes, and I just added to the stage.
Perfect.
It seems like the documentation, right?
Yes, exactly. So these are Secret Network's docs. If you just Google search Secret Network documentation, you'll pull this up. And what I specifically want to show us today, what we're going to be walking through today is the Ethereum Developer Toolkit. In this, we have an overview of how to connect Secret Network to Metis, to anyone's network who's watching, and how to do cross-chain messaging with Secret Network on Metis. And we also have specific use cases built out with full stack demos. So let's actually just look at one of these full stack demos up top, and then we'll actually go into how we implement the code. So yeah, VRF is one of our demos we have. And we have a developer tutorial, which is what we're going to actually be walking through today on today's call. And we also have this full stack application, which there's audio. So if you have audio going, maybe turn down your volume just a little bit for this app. This is kind of fun. What this is it's called Secret Balls. It's a VRF demo. And what we can do is log into our MetaMask wallet and actually execute this with Metis. And that will be passed to a contract that's deployed on Metis, a gateway contract, which then communicates with a private contract on Secret Network to request and receive verifiable randomness. So like if I disconnect my wallet and then log back in, what we'll see is all these different networks that are connected to Secret Network, other EVM L1s and L2s. But specifically, we're doing this today with Metis Sepolia testnet. So I've already received my Metis Sepolia testnet tokens. And what's going to happen is I'm going to click this button and it's going to return a random number between 1 and 200 of secret balls that are going to fall from the screen. And I didn't just showing this up top just to kind of give a demo of what's possible. You can make, games or applications, whatever. The sky's the limit. So do this, sign this transaction, and then we receive randomness. So the random number we received is 137. Cool. So that's that demo. And what we're actually going to do now is go into that code. And I'm taking you literally through the docs so that you can be empowered to do exactly the same by just going through our documentation alone. It should be that simple. You should be able to do that with Metis. And one other thing to note before we just dive into the code is that the way this is all possible is with a bridge that we built out at Secret Network called Secret Path. And essentially what it is we have a public gateway contract that exists on all the chains we're deployed to, such as Metis, and a private gateway contract, and those on Secret Network. And those contracts using elliptic curve Diffie-Hellman cryptography are able to communicate with each other and pass encrypted messages back and forth. And so, yeah, if we go to our supported networks, we go to EVM testnet, we will see the gateway address specifically for Metis Sepolia right here. And so this is what we're going to be working with today to actually be able to deploy our own randomness receiver contract on Metis to receive randomness from Secret Network. Any questions before I go a little bit further?
I don't think so. I
Okay.
think we are good to, but it looks like pretty straightforward. Like you just essentially go through the documentation step by step, right? For this
Yep.
part, at least.
Yep. And actually, this all happens like in a code base that you can clone down to your local your local desktop, to your computer. But I think we could actually just do this in Remix to keep it simple. Let me see.
Sounds good. Yeah.
Remix online. Okay. So all I'm doing is I'm just in our docs, I'm just pulling. Actually, let me just open this in another tab so you can see exactly what I'm doing. So in our docs, we show how to do this locally with Hardhat, but I'm just going to take the same smart contract from our docs and then just deploy it to Remix instead with Metis. And so like if we clone down this repo, if we actually look into what this repo is, we will see, where's this? Our RNG. We go into contracts. We have this randomness receiver.sol contract. And so this is what I'm going to deploy to Metis. And all the code is documented and commented. So if you want to kind of go line by line and understand exactly how this works, but basically it's 80 lines of code. And with this, we're able to receive randomness on Metis mainnet or Metis testnet, depending on where you deploy it. So let's just open up a blank workspace in Remix. Oops. Okay. And then we're going to create this contract file. And if I comment on StreamYard, am I able to post this link in the chat for everybody who's watching?
Yes. What you can do is share it with me, maybe on Telegram, and I can. Oh, you can share that. Yeah, for sure.
Oh, we
in
got to
the
connect
chat.
you too.
Sure
Okay,
did.
I'll send it to you on Telegram afterwards. I just want to make sure everyone has all the links we're using.
Yeah, it sounds amazing. That way people can follow along.
Perfect. All right, so I'm literally just copying this Solidity code exactly as it is. This is our randomness receiver contract. I'm pasting it in to our randomness receiver.sol contract on our remix instance. I am going to compile this. And from here, we just take this contract, randomness receiver, and we're good to deploy it to MetaMask or to Metis. So I want to make sure that the correct network is currently connected. So I'm logged into Metis testnet. And for anyone who's like completely brand new that has never even added Metis to your wallet before, if you just search like Metis Sepolia testnet explorer, this is where we can actually see our transactions. And here, down here at the bottom of the page, you'll see how to add Metis Sepolia testnet to your wallet. So I've already done that, and I've already received testnet tokens, so don't need to do that step right now, but that's there for you in case you need it. Okay, so I'm going to deploy this to Metis testnet. Hopefully everything goes smoothly. Let's see. Okay. Let's see. All right, creation of our contract is pending. And let's see what it says. We have an error.
Did you make sure to check if the EVM is Berlin?
Weirdly, I'm seeing that it's deployed here. Let me just copy this and see.
Got it.
Curious if it shows up in the Metis Explorer. Okay. It says it failed. Let's just try this again. And it could have to do with, I don't know, perhaps the Solidity version for Metis. Curious if I just downgrade this, what happens? All right, that looks like it's going to work. Let's see. Beautiful. Let's see, just double check on the Explorer. Interesting.
Awesome. So just to be clear, what you had to do in order to make it work was downgrade the version, right?
I think so, but let's see. Because it looks like it's still saying that it might be failing on the in the Explorer. Give me 1 second here. Okay. Contract address. Just double check. Oh, here we go. Perfect. Yeah. So I think that might have been the error, was I just had to, downgrade the Solidity compile version. I just put it to 0.19, and for some reason that worked, which beautiful for a live demo that we were able to solve that in 3 seconds. That's not usually what happens in a live
Usually it
demo.
doesn't go that way, but yeah, good work, Sean.
Okay, so now to actually execute this and receive randomness, all we need to do is just set the gateway address. So because this contract is created to be interoperable with other EVM L2s and L1s. And so the way we actually point to the Metis testnet to make sure that the randomness is sent back to this Metis smart contract is by adding a secret network, our gateway contract address. So if we go back into the secret docs and we go to supported networks, again, I'm just going here to our gateway contracts. And for Metis testnet, this is our gateway contract address. So I'm just going to copy this, go back to our remix instance. And now we can actually set our gateway contract address here. So, okay. Click this. So again, all that I did was just went to secrets docs, took the gateway address from Metis Sepolia, and I am pasting it in here to this set gateway address function right here. If you were to do this for Metis mainnet, the only difference would be that you would obviously deploy the randomness contract to mainnet, and then you would use the mainnet gateway address instead, which is also in our docs here. But we're doing this for testnet, so I just copy that address. I'm going to set the gateway. And then we can come back to our Metis Explorer and just see that it was successful. Let's see. Okay. So we see that our contract call was successful. Amazing. All right. And now we can actually request randomness. So I'm not super familiar with the Metis Explorer. It's a little bit different from other explorers I've seen, but let's see if we're going to actually be able to see this in the logs. All right. Yeah, so now all that's left to do is just request randomness. You can do a custom number between 1 to 2,000 bytes of randomness. So if we go back into the contract itself and we see this request randomness, this is where we actually set the number of random bytes that we want to receive. And the reason it says number of words is because that's what Chainlink VRF says. And we kind of, this contract, if you're familiar with Chainlink VRF, should look exactly like Chainlink VRF. We wanted to make it just like as accessible to EVM devs who have worked in other ecosystems as possible. But there's also this func request randomness test preset where it will return 20 random bytes to us. So we're just going to call that instead. And if you're calling this in Remix, the only thing is you just have to include some gas to pay for the callback. So let us see. Just a minute. Okay, so I'm just going to add some gas to pay for this callback. We already set the gateway address, so now we're just going to request randomness, and then we should receive 20 random words or 20 random bytes in the Metis smart contract if we're able to view the logs. Let's do this. All right, it looks like the transaction was successful. Wow, it's really cool that the Explorer just updates automatically without you needing to refresh. I feel like other Explorers don't do that. Yeah, that's... Okay, and so now what I'm looking for... Okay, I think it must be this. Okay, actually... Interesting. I guess what I'm trying to see is like, you know, in like Sepolia Block Explorer. Let's see. Yeah, but what is the section that you're trying to see? Like, I guess the logs. Because that's where the randomness is usually returned on Sepolia. Yeah. Maybe it's in this. Maybe it's just that it's... Yes, that should be it. I think that's probably the 20. Okay, so I think this is the 20 bytes. But they're just kind of like all together, hashed together, interestingly. Okay. So that's how you do this. If you just want to deploy this contract and return it as an event on Metis testnet. Let me also just, as another thing, just like show actually kind of behind the scenes how we set up this Wallet Connect integration, so that Metis devs could just like clone down this code and have like a working instance right out of the box of like being able to work with the randomness contract. Does that sound okay?
Yeah, that sounds great.
Okay. So I'll make sure to link all of this afterwards.
Sure, you can add that later to your GitHub, and we will make sure to share that with our network as well.
Okay, perfect. So, okay, this is what I'm going to open right now, Secret Path Wallet Connect. And if I go into the code, let's see. So all right. Let me just make sure that I have all of this going correctly. Give me 1 second while I just set up my environment. Okay, cool. So the demo that I showed up top, where we use Wallet Connect to be connected with Secret Path with Metis testnet and other networks as well. I want to just also now just give a brief tutorial how Metis devs can clone down this repo and then do exactly that, so that you guys can start working with Secret Path out of the box and kind of understand more behind the scenes how to actually customize and call your own Secret Path functions. So this is just like a stripped down demo of doing what we saw at the very top with secret balls. That was using 3GS. It was a little more advanced. This, though, is just a button where we can have any of these connected networks. We want to stay with Metis, and then we can request randomness from a secret network smart contract. So I'm just going to request this, and then I think it will, great, just make an alert of what our random number is. All right, so the first half of this tutorial, you should now have the tools that you need to deploy your own Metis smart contract to be able to receive randomness from secret network. What I want to show now is how to basically build a full stack application where you can connect Metis to secret and have your own custom functions that you design and work with secret network smart contracts. So if we look at what this actually is behind the scenes, this, for anyone who hasn't seen this before, is Wallet Connect. And what I'm going to speak through now is just like how to actually set up Wallet Connect so that you can do this too in your own full stack applications. So again, there's this repo that I'm going to link into the chat afterwards. It's on my GitHub, just called Secret Path Wallet Connect. You can clone this down, npm install when you're in front end, and then just npm run start, and you'll be all ready to go to just run the demo and have this exactly as it is. If we look at our app.js file, it's very simple. We have like 60 lines of code. All that's happening here is I wrote a use effect function, which all it's doing is just logging what chain ID we currently have to the console and also to state. That way, we're able to point the current chain ID to the correct secret network gateway contract. So in the same way earlier, where we had to set the gateway contract so that the Metis smart contract knew how to communicate with secret, we do the same thing here, just using the chain ID. So if the current chain ID is Metis's chain ID, that's how this React application knows to communicate with secret network for Metis. And again, this is all written out for you, so that you're able to just clone this down and get to design your own application right out of the box. So there's this chain ID function, which, like, if I open up the log, it'll just say what our current chain ID is. That's all that is. Then we have two functions that are happening here. We have our query randomness. So this is just a basic secret network function that just queries the smart contract, our randomness smart contract. And whenever the randomness is updated, we're able to just do this secret query to retrieve that random number. And then the other thing we have is our actual request randomness function. So this is like kind of like more like the nitty gritty behind the scenes, like how to actually, if you want to write your own customizable Metis contracts that communicate with secret network, this is showing how to do it. Like if we look in app.js right here, I have this abstracted to just one line of code where all we need to say is request randomness with the chain ID. So you could do this right now. Like you could clone down this code and use it exactly as it is and have a full stack demo running. But what I want to show you now is just like what this code actually looks like behind the scenes so that you can customize it should you choose to do other things on secret network. Like perhaps you want to receive a random number, but you also want to have encrypted payloads. That's what I want to teach right now. All right, so if we go into this request randomness function, this is going to look kind of scary. It's like a bunch of lines of code. It's like 200 lines of code. Most of this, though, is just this if-then logic, which is just pointing whatever chain ID you're connected to, make sure we're using the correct secret gateway address. The only thing you need to understand about this code, it's almost like 99% of it is boilerplate code so that it can effectively communicate with secret path. The only things you would need to change out in this code is if you deployed a different secret ad contract, like if you made a different randomness contract or you wanted to work with a contract on secret that was like encrypted payloads, you would just have to write your contract address and code hash here. And for anyone who hasn't heard of a code hash on secret network before because you're an EVM dev, this is just a unique hash of the actual smart contract that is unique for each smart contract. And it's kind of, I think it's specific to secret network, but when you basically every time you deploy a contract on secret, it also deploys a code hash and they're associated with each other. So all of this is already set up. You don't have to change anything. The only thing to note here is the handle. So this is what function is actually being called in the secret smart contract that we're pointing to here, right? So we're calling the request random function, which is what actually behind the scenes is doing all of the randomness verification and requesting. And I just want to point this out just in case anyone's going to take like a deeper dive, look into the code and has more questions, because this is like where you really get to the fun stuff where you can start to write your own custom contracts on secret and then be able to use a Metis smart contract as a controller that basically has access to encrypted payloads on secret. But I don't want to get too into the weeds. I want to kind of just keep this high level as possible. So yes, that's that. The only other thing I want to discuss is just how to correctly configure Wallet Connect for Metis. So up here, right, we're able to connect to Metis testnet and use this to interact with secret network smart contracts. The way you can do this, all you need to do is just go to walletconnect.com and create a new project ID. That's what it's called. So you just create a project ID for a React application or whatever front end UI you want to work with. And as soon as you have that application ID, you're good to go. Because to create this Web3 modal, this wallet modal, we just have to pass like 5 parameters to Wallet Connect to actually do that. One of which is the chain ID or the project ID for your project. So that's the thing that you create customizable in Wallet Connect. The other thing is just this metadata object where you just write the name and the description of your application. Then there's this is just boilerplate code. This others config object. Chain images is how we actually add custom images. So like this is the chain ID of the network, and this is the image for the logo of the chain. That way we can have our own chain logos. So like I did this, I added my own custom chain logos for Metis mainnet and testnet, for example, because I wanted the UI to look pretty. I wanted us to have your guys' beautiful logo there. And then lastly, there's the actual chains that we pass. And this is just the config for Metis. So if I go into what this information actually is, if you've ever like created a custom config in MetaMask, for example, it should look exactly the same. So it's just like your RPC endpoint, and you're just passing that to Wallet Connect so that it knows how to connect to that network specifically. And with that, you're able to just generate your own Wallet Connect application and in this way be able to be connected to the interchain. Okay, we're at the half-hour mark. I know I just threw a lot of information out there, but my hope for this is that at least Metis developers who've been watching now have the tools to deploy their own Metis smart contract that can request randomness from secret and also understand how to set up this full stack UI so that you can interact with secret network smart contracts on Metis.
Yeah, no, thanks for sharing. It looks like pretty straightforward. I'm kind of surprised because I was like kind of expecting something much more kind of difficult, but you guys work it out like a really nice boilerplate. So congratulations to you guys.
Thank you. Thank you. Yeah, it's been fun to just kind of, I think it's just fun, like the interchain world is here. It's happening and we're seeing it being built before us. And I think it's because of conversations like this. Like I never thought that a Cosmos L1 and, an Ethereum L2 would be able to build things together and have like real world use applications.
It's crazy. Yeah, I find it very crazy to be honest. So, I mean, it's amazing. Yeah, totally agree with you there. I am not sure, guys, for the people that are watching, if you have any questions, please feel free to add them on the chat and we will be replying to you. And if you don't have any questions now, but you are going to be watching this in the future and want to ask anyway, just join our Telegram group on the Metis Developer chat. Are you there, by the way, Sean?
I am, yeah.
Awesome, awesome. Yeah, we try to share, these links to workshop, and you can ask, and you have. I'm not sure if it's like 24/7 service, but there is always someone there that is willing to help you, whatever the stage it is that you are in your Web3 developing journey. Like you can be just getting started, and we are going to be providing some resources. You can fork this repository and get started with that. And if you have any questions, I will be there. Sean will be there. So yeah, it's pretty much like a lot of support that you are going to be able to find. On your end, Shan, I wanted to thank you for joining us today, and I wanted to give you the opportunity. Maybe you want to share something else in terms of maybe a call to action for developers to try to use this, or to what should they do next, or where should they join in terms of your channels.
Yeah. Okay. So I'll be in touch with you, Victor. But something we want to launch next week is like an incentivized campaign for Metis developers to actually deploy their own randomness contracts. And then and they'll be entered into a raffle that uses secret VRF to pick one of the so whoever deploys, they just submit their wallet address and the address of their deployed contract, and then they'll be eligible for this secret raffle where they can win 50 secret. And our hope is just to get as many Metis developers as possible, just comfortable to actually be using secret VRF and also deploying their own Metis contracts that enable randomness. So I'll be sure to, I'll link you to that next week and we can figure out a way to kind of, I guess, communicate that to everybody.
Yeah, for sure. We will need to work on the communication front to share this with enough time so that our developers can prepare. It sounds very exciting, and I can't wait to give it a try. So thank you one more time, Sean. This has been an amazing demonstration. And for the people in our community that are watching, please make sure to subscribe to our YouTube channel. And if you have any suggestions, comments, or things that you would like to see in the future in terms of educational material, please feel free to ask or post in the comment. We read everything. So other than that, I wish you a nice rest of the day and a nice weekend, Sean, and everybody else who is watching.
Thanks so much, Victor. Yes, like and subscribe, everybody.
Yes, please. Thank you, guys.
Thank you.
To end the stream now.